resistors connected in parallel. Consider two resistors of resistance R1 and R2 connected in parallel to X and Y. For a current I passing through this combination, we say the current in R1 is I1 and the current in R2 is I2. When the resistors are connected in parallel, the potential difference or the voltage across each resistor is the same. That means V1 equal to V2. By Ohm's law, we have V1 equal to I1 R1 and V2 is I2 R2. Therefore, I1 equal to V1 over R1 and I2 equal to V2 over R2. Since V1, V2 are equal, we call V1 equal to V2 equal to V. Therefore, I1 becomes V over R1, I2 is V over R2, and V is the voltage across XY, which is equal to V2 and equal to V1. Hence, I1 plus I2 equal to V over 1 over R1 plus 1 over R2. Or we say the total current I equal to V times 1 over R1 plus 1 over R2. If now we use a single resistor of resistance Req, or we say the equivalent resistance, to replace the combinations of R1 and R2 on the condition that the currents are the same and the voltage across XY are the same. By Ohm's law, we have I equal to V over R equivalence. By comparing this equation with these equations, we have 1 over R equivalence equal to 1 over R1 plus 1 over R2. And this formula is very important to find the equivalent resistance for resistors connected in parallel. There is a shortcut to find the equivalent resistance for resistors connected in parallel. Consider this case. One over Rxy equal to 1 over R1 plus 1 over R2. By rearrangement, we can find that the equivalent resistance across XY, or we say Rxy, can be written as the product of the resistor R1, R2 over the sum of the resistance R1 plus R2. In fact, this formula is very useful to find the equivalent resistance for two resistors connected in parallel. How about if there are 1, 2, 3 resistors connected in parallel? In fact, this formula can still be applied. In this case, we have 1 over R across 1, 2 equal to 1 over R1 plus 1 over R2 plus 1 over R3. If we have more resistors connect in parallel, then the summation side can still be added on, etc. Example 1. Case 1. 1 over R across xy equal to 1 over 10 plus 1 over 10, which is equal to 1 over 5. Therefore, Rxy equal to 5 ohms. Another method is R across xy equal to product of the resistance over the sum of the resistance, which is equal to 10 times 10 over 10 plus 10, which is again equal to 5 ohms. For case 2, we have 1 over R across xy equal to 1 over R1 plus 1 over R2 plus 1 over R3 equal to 1 over 3 plus 1 over 3 plus 1 over 3 equal to 1. Therefore, R across xy equal to 1. For case 3, we have R across xy equal to the product of the resistance, which is R1 over R1 R2 over the sum of the resistance, which is R1 plus R2, equal to 1 times 10 to the power 6 over 1 plus 10 to the power 6, which is approximately equal to 1 ohm. From these cases, we notice that for resistors connected in parallels, the equivalent resistance must be smaller than the smallest resistance of the circuit. For case 1, the smallest resistance is 10 ohm. For case 2, the smallest resistance is 3 ohms. And for case 3, the smallest resistance is 1 ohm. Consider two resistors of resistance R1 and R2 connect in parallel. The main current or the total current is I, and the branch currents is I1 and I2 respectively. And the voltage across 1 and 2 is V1 and V2 respectively. For resistors connected in parallel, we have V1 equal to V2. By Ohm's law, V1 is I1 R1 and V2 is I2 R2. Hence, we have I1 over I2 equal to R2 over R1, which means that the current in each resistor is proportional to 1 over the resistance of the resistor. Or we say current I and resistance R are inversely proportional. Also, the total current I is equal to the sum of the branch current I1 plus I2. For example, if R1 equal to 10 ohms and R2 equal to 20 ohms, and the main current is equal to 3 ampere, then we have I1 plus I2 equal to 3. V1 equal to 10 times I1, V2 equal to 20 times I2. Because V1 equal to V2, therefore 10 I1 equal to 20 I2. By solving these two formula, we have I1 equal to 2 A and I2 equal to 1 A. Hence, we can find V1 equal to V2 equal to 20 volt. Since I is inversely proportional to resistance, when resistors are connected in parallel, therefore, the smaller resistance resistor will have a greater current. Example 2. Part A. Equivalent resistance of the circuit is found by 1 over E equivalent equal to 1 over R1 plus 1 over R2 plus up to 1 over R100 equal to 1 over 10 to the power 3 plus 1 over 10 to the power 3 up to 1 over 10 to the power 3, which is equal to 100 over 10 to the power 3 equal to 0.1. Therefore, equivalent resistance in the circuit equal to 1 over 0.1, which is equal to 10 ohms. And the total current I can be found by using Ohm's law, which is equal to V over R equivalence, which V equal to 6, R equivalent is 10, therefore I equal to 0.6 A. Since all resistors have the same resistance, therefore the current in each resistor, I1, I2, up to I100 are the same. Therefore, I1 equal to I2 up to equal to I100 equal to I over 100 equal to 0.6 over 100. That is equal to 6 times 10 to the power negative 3 A, or equal to 6 milliamp. For part D, the voltage across each resistor. Since the resistors are connected in parallel, they have the same voltage, which is equal to 6 volts.